MCP stands for Model Context Protocol. It is an open standard that defines how AI models connect to external tools, data sources, and services. An AI model on its own can reason and generate text, but it is isolated. It cannot check a live exchange rate, query a database, or send an email. MCP bridges that gap by giving AI models a standardized way to reach out and use tools in the real world. There are two sides to MCP, the server and the client. The MCP server is the side that exposes tools. It is a program that wraps an existing capability, an API, a database, a file system, and makes it available through the MCP protocol. The server declares what tools it offers, what inputs they accept, and what they return. The MCP client is the AI model or application that connects to the server and uses those tools. The client discovers what tools are available, decides which one to call, provides the right inputs, and receives the result. Claude, for example, acts as an MCP client when it connects to an MCP server to take actions on a user's behalf. This separation is what makes MCP powerful. You build a tool once on the server. Any MCP-compatible client can use it immediately, no bespoke integration required for each one. Now, let us look at how to actually build an MCP server. The most common approach in Python is using the MCP SDK with the @tool decorator. Here's how it works. You import the MCP library and initialize a server instance. For each tool you want to expose, you define a Python function and decorate it with @tool. The function name becomes the tool name. The docstring becomes the tool description. This is what the AI model reads to understand what the tool does and when to use it. The function parameters become the tool inputs, and the return value becomes the output. Let's use a currency conversion API as a concrete example. Say you want to give an AI model the ability to convert between currencies using live exchange rates. You define a function called convertCurrency. It accepts three parameters: an amount, a source currency code, and a target currency code. The @tool decorator registers it with the MCP server. The docstring is critical here. It should explain clearly what the tool does, what each parameter represents, and what the function returns. The AI model relies entirely on this description to understand when and how to call the tool. A vague docstring leads to incorrect usage. A precise one gives the model exactly what it needs. Inside the function, you call your exchange rate API, retrieve the conversion rate, calculate the converted amount, and return the result. When the server runs, it exposes this tool through the MCP protocol. A connected client, like Claude, can see that a convertCurrency tool exists, read the docstring to understand it, and call it whenever a user asks something like, "What is $500 in euros?" The server handles the API call, the client handles the reasoning. Neither needs to know the internal workings of the other. A few things worth keeping in mind when building MCP servers. Write precise docstrings. They are not optional comments. They are the interface the AI uses to understand your tool. Treat them as carefully as you would a public API. Keep tools focused. Each tool should do one thing well. A tool that does too many things is harder for a model to use correctly and harder for you to maintain. Return clear errors. If something goes wrong, return an informative message so the model can communicate the problem rather than failing silently. And keep inputs simple. Prefer basic types, strings, numbers, booleans, over complex nested structures. The simpler the interface, the more reliably a model will use it. MCP servers can be as minimal as a single tool or as comprehensive as a full suite of capabilities. The protocol scales with your needs. What stays consistent is the pattern. Expose tools with clear descriptions, let the client handle the reasoning, and keep the two sides cleanly separated.